Assalamualaikum and hello everyone. Today, our group will be presenting application and reaction of organic compounds. We are choose acetone as a compound from the ketone functional group. First thing first, I will introduce me and my group members. My name is Nur Zulaika binti Zulkifli and my group members are Nur Aisyah Hazwani binti Amiruddin, Nur Alia Shazwani binti Roslan, and the last one is Nur Aifatiha binti Muhammad Afizan. I will start the introduction first. Acetone, also known as propantoone or propanone, has molecular formula C3H6O and the structural formula CH3 2CO. The structure: a central carbon atom double bonded to an oxygen atom and single bonded to two methyl groups. Acetone is from ketone functional group. Acetone is classified as ketone because its carbon is attached to two alkyl groups. It is the simplest aliphatic ketone, and ketone is not primary or secondary alcohol, but a true ketone.
Next, the application of acetone. Acetone, also known as a propanone, is a powerful organic solvent. It is widely used because of its ability to dissolve many substances. In a polish, acetone acts as a solvent that can restore viscosity when the polish becomes thick or dry out. Its molecules wedge themselves between the long polymer chains, such as nitrocellulose, causing the polish to swell and soften. This makes the polish usable again or easier to remove. So, whether acetone is suitable for nail polish? From a chemical perspective, acetone is classified as a polar aprotic solvent. Nail polish itself contains complex polymers like nitrocellulose, resins, and plasticizers. Acetone's carbonyl group, the C-double-bond-O, has a strong dipole moment. This allows acetone to interact with both polar and non-polar components in nail polish. By doing so, it disrupts the van der Waals forces that hold the nitrocellulose polymer chains together. As a result, the polish loses its strength and dissolves.
Next, reaction of acetone. First, reduction of acetone. Acetone, a ketone, is reduced to isopropanol, a secondary alcohol. For example, propan-2,1 react with lithium aluminum hydride to form propan-2-ol, which is propan-2-ol is isopropanol. The key point is the carbonyl group C-double-bond-O is reduced, hydrogen is added, ketone is converted into secondary alcohol. These are the common reducing agents. First, lithium aluminum hydrate. Second, sodium borohydrate. And third, hydrogen gas in the presence of the metal catalyst. Next, nucleophilic addition. Acetone react with hydrogen cyanide to form a cyanohydrin. For example, propan-2-on react with CHN to form 2-hydroxy 2-methyl propanitrile. The key point is Cn negative act as the nucleophile and attack the electrophilic carbon of the carbonyl group. After protonation, OH group is formed. Product is called cyanohydrin.
So now we will looking at how acetone react with hydrazine to form hydrozones. Under reflux in ethanol, these two react to form acetone hydrozone and water. For the mechanism, first the lone pair on the hydrozine's nitrogen attacks the electrophilic carbonyl carbon of the acetone. This creates a short-lived intermediate where the carbon is bonded to both an oxygen and the hydrazine group. Next, hydrogen moves from the nitrogen to the oxygen within the molecule, and finally a molecule of water is eliminated, creating a carbon-nitrogen double bond. For the last one, we will looking at how acetone react with 2,4-dinitrophenylhydrazines, also known as 2,4-DMPH. The mechanism here is exactly the same as before, which is acetone with hydrazine. However, the product 2,4-DMPH is much more significant in a laboratory setting. So, basically, the hydrogens are often liquids or oils, while 2,4-DMPH are typically bright yellow or orange crystalline solids. Because of these precipitates have very sharp, distinct melting points, chemists use them to identify unknown aldehydes and ketones. If you have an unknown liquid, you react it with 2,4-DMPH. Measure the melting point of the resulting crystals and compare it to known values. To wrap up, these reactions are fundamental tools in organic chemistry for the derivatization and identification of carbonyl functional groups.